Hello and welcome to our next lesson in our geometry chapter. This is going to be our fifth page, at least my fifth page in our notebook. And we're going to talk about 1-2 line measure. Now, last class we talked about points, lines, and planes, and specifically lines, by our definition, went on in both directions. In this particular class, we're actually going to get a new type of line measure, and that is a segment, or line segment. Now, a line segment is a little bit different than a line. It can be measured and has two endpoints. So a line segment is a line, and let's not say line. Let's say this can be measured and has two endpoints. So this is going in a notebook. But also note, this still has infinitely many points. And I'm sorry, I should have drew a diagram first. But this doesn't go on forever. Does not go on forever. So this is what I mean. Okay. In the past, we had lines. Segments have endpoints. So this is a line, and this is a segment. Segment has two endpoints. It can actually be measured, the actual length of it. So if we call this A and B, versus here we could have A and B. So I'm going to use the same letters on purpose, and you'll see what I mean in a second. In this version of a line, it goes on infinitely in both directions. However, this one can actually have a length. You could say AB is equal to, let's say, 2 inches, versus here AB goes on forever. Now, also note that the names of these are almost the same. We see that AB, the line, has the two arrows. Let me highlight this. Versus AB, the line segment, has the endpoints. Okay? And they are very different. So that is something to keep in mind. Now, no, that's good. So that is a line segment. Okay. We will next go into congruent segments. So let's talk about congruent segments. This is a little bit of, I guess, a sub-part to segments. And here, congruent means equal to, or same as, same measure. So a congruent segment is segments that have the same measure. Or in other words, they are equal. In geometry, we don't say equal, we say congruent. For instance, we'll see a segment, two endpoints, and let's call this M and then Y. I'm going to do another segment and we'll call this O and P. Now, how do you know these two are the same length? And that's what this is saying. They have the same measure. I'm going to say that these two are the same length. Well, you could actually tell that these two things are the same length by what these little tick marks are. Okay, and I'm going to do this in red. This is a tick mark. And notice there's one tick mark. That means when you see that same tick mark on OP, they are the same length. And this is your indicator of congruency. So if you ever see something with the same tick marks, then they are the same length, okay? If you see them with different ones, and let's do another side one here. Now, these two lengths look like they're the same. And let's call this, let's say AB again, and let's call this X, Y. Now, I'm going to put 2 tick marks here on AB, and then 3 tick marks on XY. That tells you that these are different lengths, because they have different tick marks. Different lengths. Okay? So the tick marks are very, very important in telling you how many or how long something is in terms, or difference in lengths, or possibly congruency in lengths. Okay? And a little bit of a note. The way we write it, the way we name these, we're going to say MY. I'm going to make sure you don't put the arrows here. It's going to be congruent, and this is the weird part, and it's not an equal sign. I remember it says equal to, right? But in geometry, when we say congruent, we put this little tilde on top, okay? And that is the congruency symbol. Congruent symbol. It's the equal sign with a tilde on top. MY would be congruent to OP. Okay? Excuse me. Now, you don't need to know what this length is. So for instance, if I said this was 12, you could easily say this is 12. And so on and so forth. If this was 5, this is also 5. But the fact that you don't have to have a measure there to know that these are equal to each other, they are just in fact equal to each other. Or likewise, AB, if you said this is 6, you know that this is not 6. It has to be some other length. It could be 6.1 or 6.2. It could be really close to it, but it's not the same length. Okay? Last definition of the day, and then we would be done with definitions. We could talk about, or we could do a little bit of some practice problems. Is betweenness of points. This is our last definition of this betweenness of points. And I'm going to start this one off with a diagram. Let's go example. And we're going to go we're going to do a line segment. I'm going to call this P. I'm going to call one end Q. And then between this of points literally means that we have some point that is between, or in between, in the middle. So I'm going to put M here for middle, a point that's between them. It's important to know that M is not necessarily right in the middle. In the middle of PQ. Okay, it can be, but it's not necessarily. Okay, so between this of points states that point M is between P and Q. If and only if P, Q, and M are collinear. So there's one of our definitions again. Oops, collinear. And this is going to be the weird one because this is going to look like a math problem. PM plus MQ is equal to PQ. Now, hopefully this makes sense, and I'm going to give you an example for this. Let's pretend this length here is 2. Then I'm going to use a different color. MQ, let's say this is 4. Well, hopefully this is obvious. That makes this whole length 6, because 2 plus 4 is 6. And if you really, really look at this equation, PM, we wrote down, is 2. MQ, well, let me do this in the colors that we used. PM, here is 2. MQ is equal to 4, thus making PQ equal to 6. Okay, and we get math equations out of this. Sometimes you'll have variables here. Sometimes you'll say, oh, we don't know what PM is. We're going to put an X here. So we could actually do the math for it. The only way this makes any sense is that if PM is equal to 2, and you'll see what I mean in just a second when we actually have problems like this. So we could definitely have equations that look like, not what I'm trying to do, for these problems, for these segments, okay? And let's take a look at least one or two of these. So, here is our practice of the day, and here's a perfect instance. If we're looking for the length of RT, RT is the length of RS plus ST is equal to RT. And all we really have to do is add these two together. 2.0 plus 2.5 is equal to 4.5. Thus, we could actually just jump to the conclusion. RT is equal to 4.5. Make sure you use the units that we're talking about, centimeters, and we're done. Here's an instance where we actually don't know the length of something. So if you want to put an X here, that's perfectly fine using variables, but we do know the final length. So in this case, 2 3/4 plus X is equal to the full length of 6 inches. And we could do some math. We could do some algebra. Minus 2 3/4 to both sides. Now, if you want to do a little bit of borrowing, you can. 5 and then 4/4 to make that 6 inches. 4/4 minus 3/4 is 1/4. 5 minus 2 is equal to 3. Make sure you use our measurement, inches. Thus, BC, this is a segment, remember, we're not using the arrows, is equal to 5 3/4. 5 and 3 1/4 inches. So here's a case where we're looking for the actual length of it, and we have to do a little bit of math. I trust that you should be able to do this on your own. AC, find this length. DB, find this length, etc. Okay. Here we have some tick marks. What segment is congruent to JM? I trust you should be able to do this because of the tick marks. But there is one that I do want to touch base with, and actually both of these two, and then we'll call it a day. Find the value of X and RS, and this is important, and it says and RS, if S is between R and T. So S will always be between R and T. So here, I'm going to go ahead and draw this diagram right off the bat. R, T are on both ends. S is somewhere in the middle. We don't necessarily know where, what the length is. And I wrote to draw the diagram. So we already drew it out. It's ready to go. So in this case, RS is 2x. ST is 32. And this entire length here is 5x plus 2. So we have an equation because one part plus the other part makes the whole. So we have 2x plus 32 is equal to 5x plus 2. Okay, hopefully you could see how I came up with that. I added these two parts of the segment and made the whole segment. So let's do some algebra. Bring the variables to one side. I'm going to bring this to the right side. I'm going to bring with the numbers to the left. Oops, that cancels out. We get 32 is equal to 3x plus 2. Subtract 2, subtract 2. Oops, wrong one. And we get 30 is equal to 3x. And we divide both sides by our 3. We use our reverse order of operations and inverse operations. And we should get 10 is equal to x. Now, be careful. It looks like we're done. But remember, do what the question's asking you to do. We found the value of x, which is great, but it's asking you to also find RS. So in this particular case, we need to plug this in. RS is here. So RS is equal to 2 times 10. And we could say RS is then equal to 20. And we are done. 20, it doesn't say what the units are. So we just say 20. We're done. Okay. I trust you should be able to do 11 with that particular problem. And with that said, I think you are good to go for this particular section. Okay. If you do have any questions, please reach out, and I'll see you in the next one. Bye.